Hello and welcome back to another video. In this problem, we're asked to make a rough sketch of the graph of the function y equals e to the absolute value of x. We're not going to use a calculator, just use the graphs given in figures 3 and 13. Here we have y equals e to the x, and if necessary, use the transformations of section 1.3. So what we're going to do here is I'm actually going to draw a separate xy plane, just so we can differentiate the two functions easily. And think about what transformations we have to do on the original function y equals e to the x to get to e to the absolute value of x. And what we can do is turn this into a piecewise function. So y equals e to the absolute value of x. This equals, if x is positive or equal to 0, this is just e to the x. So we can start at x is equal to 0 and just draw the same function that we had. If this is x is less than 0, then this is equal to e to the negative x. This function, e to the negative x, looks like this. It's the reflected across the y-axis, the reflection across the y-axis of e to the x, right? Which we know from these transformations of section 1.3, a subtraction within the function means you're reflecting over the y-axis. Therefore, it follows this function when we're less than 0. So this bit right here. So our final result looks a little bit like a parabola. It's not, it's an exponential, with both sides mirroring each other. And we have some important points. I don't know if I fully graphed it properly, but we have the point 0, 1, and then we want 1e, which I guess we didn't quite hit, and negative 1e as well. The graph should go through those points, but other than that, you just need the rough shape that it's mirrored across the y-axis, positive onto negative, because of this absolute value.